really don't know where the other two are. Reminder, no class Friday. It's Good Friday.
Yeah.
So I think I talked, was this the last slide on Monday that I put over?
Yeah.
Okay.
I didn't finish writing it down, that's why I'm writing.
Okay, so during heat stress, we want to reduce the crude protein, but you still want to keep your amino acid levels higher. So essentially, we're reducing our non-dietary essential amino acids, where we're keeping our limiting amino acids. We maintain them, so they actually end up going as a percentage of the protein, they go up. You reduce the carbohydrates and you increase the amount of fat, and that's because we want to increase the density, the energy density of the diet. This is a point in time where it's very critical to have very digestible nutrients. So I was mentioning Monday, you may switch, instead of having soybean meal and distilled dry grains, you during the summer months may go to a poultry byproduct or a meat and bone meal that's going to be very easily digestible. They don't have to worry about trying to break down a cell wall and cause that complication. Sometimes, and this isn't too common, but I guess if it's really bad, some areas they'll withdraw feed between the times of the heat of the day, between 10 and 5. Downfall to that is if you've ever seen broilers that have been feed restricted, they will at 5 p.m. act like they're starving because
We used to, when I worked at our unit, we would only feed them in the morning. So when we came back in the next day, they're screaming and hollering.
right.
As soon as you get in, so they get fed.
Broilers go in that 7 hours without feed. When that feed does come down, like they're going to, or if you just turn off the feeders and don't raise them, and it's the auger system, they climb into that feeder and they'll get stuck and die. So that's some of the difficulty and things that you have to be aware of. So that's another reason why that's not the best thing that we do. Not too many people will do that. Sometimes you add a little bit of salt. Just that little bit of salt is going to keep them drinking. So if you remember when I talked about salt, salt really isn't toxic unless you limit water. So having a little bit of salt in the water, that's going to keep them drinking more, and them drinking more is going to help cool them down. And you want to keep the water cool. That's critical, so it lowers their body temperature. I think we talked about this a little. So our gut health, so especially with our broilers, it's very easy to forget that we're dealing with babies, right? They're when we send them to harvest, they are 35 to 42 days of age. They are 5 to 6 weeks. They are still very much babies. They have very rapid development of the gut epithelium, and because of that, when they first hatch, their gut is not fully developed. You don't have all the tight junctions that are critical for the epithelium all to be developed. So they're more susceptible at the younger age, the starter age, they're more susceptible to pathogens at that point in time. That's the more likely time in which they're going to get salmonella. If you infect them with salmonella by feeding it to them when they're 6 weeks of age, you're not going to get salmonella within the meat. If you give it to them at the day of hatch, they will. Mycotoxins, so mycotoxins are toxins that are released from various molds. And then you have some animal and plant toxins that will delay development. So some of those plant toxins are gonna be like gossypol, that's gonna affect that gut health. Our biggest thing that we're always worried about is bacterial and parasitic infections. Do you guys remember the primary parasite we're worried about with broiler chickens? Not E. coli, but it's coccidia. The scientific name is Amaruli. I don't remember how to spell that. So coccidia are little parasites. They're tiny. They have various oocysts. They embed themselves within the epithelium. So it's not like they transfer into. It's not like they're like histomonas that embeds and ends up going to other organs. They stay embedded in the GI tract, and the various amaruli are going to be specific to a particular portion of the GI tract. And these parasites are specific only to poultry, right? You don't have to worry about getting coccidia from chickens or turkeys. So they embed themselves into the intestine, and it ends up causing very bloody stool. So because you end up breaking the capillaries, and you can get a guess as to which type looking at the blood and the feces. If it's very, very brown, bloody feces, it's high up in the GI tract, and that blood has been digested. If it's lower, if it's in the ceca and the large intestine, it's going to be a brighter red. So that kind of gives you some idea of which coccidia you have. When you have coccidia, you get secondary bacterial infections. The primary one that you get is Clostridia. So when you add coccidia with Clostridia, you get this thing that's called necrotic enteritis, to where it's a very unhealthy gut. The villi are really small. You have blood lesions everywhere. And so when you have necrotic enteritis, so necrotic is the GI tract is breaking down, enteritis is the epithelium of the intestine, so that's what that means. So this necrotic enteritis is a very generic term, and primarily the things that are causing it are coccidia and Clostridia. So this is the biggest thing. If you don't have the GI tract healthy, you're not going to be able to absorb all the nutrients, and you're not going to grow as well. And if you have a bird that's not growing well, you're not going to be making as much money at the end of the day. So this is part of the reasons why we put anticoccidials in the diet, and where the antibiotics also helped. So now that a lot of people have gone, we've had this surge in necrotic enteritis in the past 10 years. So what happened in the poultry industry in the last 10 years? The people started demanding.
Antibiotics?
No antibiotics. So you'd have no antibiotics, and some even would have no coccidia in there. So that's resulting in that you get those two things combined, you're going to get necrotic enteritis. So taking those out has made this a bigger problem. So now we're looking at alternatives to antibiotics. We give probiotics, we give prebiotics, we vaccinate the birds against coccidia instead, and that helps us maintain our antibiotic free. A lot of people if you go to various scientific conferences, everybody, the big thing is looking at the microbiome, right? That's the key word. If you put microbiome in your grants, in your paper, you're like bound to get it accepted, because that's what everybody wants to know. Downfall is we don't know what a good microflora or a good microbiome means yet. Not to say that it's not valid, but we don't know in a healthy bird what type of bugs we want in the GI tract. So the only thing that we can see is differences. So we can say we've had a shift going from this healthy bird to this unhealthy bird. And then we can also put in the diet these non-pathogenic microbes, so those are our probiotics. And the various things related to probiotics is that they help, they compete for pathogens to bind to the intestine. They make metabolic compounds that are toxic to pathogenic bacteria. They decrease the pH. They signal to the immune system to be active within the GI tract. So those are all things that we do to improve gut health. So main things that a lot of people are looking at. So antibiotics. The fun thing about antibiotics, and I find this very intriguing, is that we don't know how they work as a growth promoter. So all of these are for growth promoters. We know how antibiotics work to treat diseases. If you get strep, you get strep throat, your doctor puts you an antibiotic, we understand how that works. But how antibiotics are working as a growth promoter, we don't understand. How is it, what signals, is it changing the microbes, is it signaling something else? We don't know. Fun fact is, do you guys know when antibiotics were first discovered in the current modern era that we're in? So it was in 1929. You know who discovered them? Alexander Fleming. So he's the one that discovered antibiotics. So he's the one that discovered penicillin, right? You guys remember that he had a mold growing and the bacteria wouldn't come close to the mold, and he knew that the mold was secreting some compound that was killing the bacteria, keeping that from growing in the petri dish. And it took him, he didn't know, because he's not a chemist, he didn't know how to extract the penicillin from the petri dish. So imagine, like, you have this groundbreaking thing that you just discovered that you have no way to capitalize on it. And finally, after 11 years, he got two chemists to help him. He was just about to throw in the towel. He got two chemists, I don't remember their names, but they were able to isolate penicillin in 1940. So 11 years later, he published the paper in 1929, and in 1940 they published the paper, this is how you extract the antibiotics out of the media. Do you know how long it took from that point in time where we extracted penicillin out of media until we started putting it in animal feed? You ever guess that? 1946. So 6 years. And so the 1940s, that 10 years, was really the heyday for discovering various antibiotics. So we would then start culturing all sorts of molds and figure out, well, this kept this bacteria from growing and this kept this from growing. So we discovered about 100 different antibiotics within that 10-year time frame. Once we figured out how to extract it from the media, it was like gold rush, right? Looking at that. Well, there was a paper written in 1946. I don't remember the author. I used to know. But they did a study and they wanted to know, okay, so there are nutrients that microbes make, some being B12 and vitamin K, that if we are giving these animals antibiotics, we need to know how much more we need to incorporate those vitamins into the diet so they grow well. So that was the whole objective of the study. And in the discussion, there was one sentence, and this was done in chicks, said, chickens that were given the antibiotic grew better. Boom, it was over. That statement alone ended up resulting in then the next 4 years, 4 or 5 years, everybody, well, let's try this antibiotic, let's try this antibiotic. And they gave low doses of antibiotics, saw consistently that the animals grew at a more efficient rate. Any guesses as to when the first warning was on I don't think we should feed antibiotics to animals?
47.
Close. 1951 was the first papers like, we need to slow down on this. Europe started trying to get things passed through. In the UK, they tried to get it passed in the parliament to take antibiotics out in the 60s. US tried in the 80s. Switzerland was the first one to ban it in the 90s, followed by Denmark. So when everybody was all up in arms last year, what are we going to do without antibiotics in our animal feed? It's been, so my mother was born in 1951, so for 60-something years we knew that we needed to be, that this was not the greatest plan. We look for alternatives to antibiotics, but we still don't know how those antibiotics are working. So how do you find an alternative when you don't know how it works? What we do is we feed this thing to a chicken, we weigh the chicken, we weigh how much feed it is. If it was more efficient, we're like, oh, this worked, this is a good alternative. If it doesn't, we say, oh, no, that's not good. But nobody, or very few people have actually looked at mechanisms, what's signaling, what's causing these changes. Some of the things that we've looked at as alternatives is probiotics, as I mentioned earlier. So these are non-pathogenic microbes. They promote gut health. A common one is lactobacillus. That's probably the most common. So a probiotic is when you're giving a live microorganism. A lot of times probiotics are also referred to as direct fed microbials. Or DFMs, direct fed microbials. And I don't remember necessarily the reason for that. Partly, I think, is because probiotics doesn't necessarily, it could have been alive at some point in time. Direct fed microbials is that it's actually being fed, it's not given any other way, and they're alive. And for our prebiotics, these are essentially giving things to promote the growth of our natural probiotics, which are called commensal bacteria. So our commensal equals our natural probiotic. So if we feed our own good bacteria in our gut, provide them the things so they'll flourish, so then they fight off any of the pathogens. So those are the different, we just kill everything, we give we give the desirable probiotics. The downfall with this, they're giving the probiotics is every company, they've gone in and they've isolated their specific clone of whether it's lactobacillus or pseudomonas or one of the other ones. So they are like, we have it, this is the best strain, and this is going to replace all antibiotics. And this one clone. I don't buy that. Probably you need to figure out a mixture of the various probiotics that need to be worked, because the likelihood of it just being one is pretty slim. In addition, these probiotics need to be fed consistently, so the animal, if they're not given it the probiotics that are fed in the diet, they don't adhere as well to the intestine. So they have to be fed consistent. As soon as you stop feeding them, they're gonna die. So that's why some people say we do prebiotics. There are other companies that recommend conveniently that you use their probiotic with their prebiotic to make things better. Metabolic diseases. So one of the things that selecting birds to grow in a very rapid rate at a young age. So when we're selecting these birds for growth, and I'm going to assume that we're going to have this with fish, it's just not yet there with the more of the farm fish, especially with how fish are so much more efficient than poultry. We'll eventually get to the stage where we have metabolic disorders that we end up selecting, inadvertently select for. So metabolic disorders are things that when we're selecting for our high yield birds, we end up selecting for a phenotype. You guys know what a phenotype is?
Heard of it.
Pretty much it's not your genetics, but your look.
Right, so it's the result of the genetics. So like me having my brown hair, right? This is my phenotype, where Tyler's hair is a little darker, right? So there's more than one gene that's controlling hair color. But if we wanted to have only my colored hair, you just force a breeding thing to where, almost kind of like the Nazis did in the 40s. To where you're breeding animals for physical trait, but there are multiple genes that are affecting that. So we have changed thousands of genes, but it looks like there's just one phenotype. So we've gotten high yielding, fast growing birds. Along with that, we ended up selecting for some metabolic disorders. One of the ones that's common is ascites, and this is referred to also as water belly. So the layman's term is water belly. And essentially you get accumulation of fluid in the abdominal cavity. And you'll see these, essentially it's an indication of heart failure. So the heart is having to work really hard to push all the blood, and it can't keep up with respiration, and you end up having the plasma out of the blood, plasma leach from the liver, and it goes into the abdominal cavity. So all that water, it's not really water, it's plasma. So it's a result of inadequate oxygen. So that's caused by the heart having to work a lot harder. You have increased blood pressure builds up in the liver, and then the liver just can't handle it, and it ends up leaking out of the liver. You will get ascites if you have low energy feeds so low energy but high amino acids. You can get them in a mash diet rather than pelleting. And then you can get them with, if you do skip-a-day feeding, which nobody really does. Another metabolic disorder, which I don't know if I have on here. Okay, this is another one, which is that sudden death syndrome. This is happening, this is kind of, I think I talked about it a little bit on Monday, where it's your fastest growing birds, they just die. No explanation, looks like they have a heart attack. So it's common with the males that are at their max growth rate. Typically is gonna start happening around 3 to 4 weeks. Really, you can only confirm it with necropsy, but typically these are the ones when you walk through the house and you'll see them on the floor and they're laying on their back. So the best way that you can
Is it kind of like a heart attack or whatnot?
basically, that's what everybody is kind of attributed into. You do a necropsy and you can't really tell what killed them. They just die instantly. So that's why we call it sudden death syndrome. And you'll see it, especially if they get stressed. You walk through the house and you stress them out, you'll just have them drop. They'll just start having heart attacks and die. I don't think I have it on here, but another one, we'll go through this. So another skeletal disorders, tibial disc chondroplasia. So this, I think we talked about when we were talking about vitamin D and calcium and phosphorus. So being deficient in that, and those three can cause tibial disc chondroplasia and rickets. This used to be a big issue. We've really reduced it with genetics and increasing the vitamin D and the availability of the calcium and phosphorus. If you slow the growth rate down a little bit, so that allows the bird to put more of its energy to the skeletal integrity, because a lot of times the tibial disc chondroplasia, they end up having so much weight put on, their skeletal system ends up being compromised. So you also want to make sure you have the proper calcium phosphorus balance between that, and that ideally is the 2-to-1 ratio that we want. So, let's see what else we got here. If you looking at our carcass, feathers, and skin, we have gender differences. So typically the females are more fat once you get above 2 kilograms than the males, and that makes sense because they need to start, even though they're still babies, they need to start planning and storing fat so they can have enough energy, so if they did make it to sexual maturity, that they would be able to lay eggs. So you end up getting more fat in the females. The biggest thing is that our energy and crude protein, they have the biggest influence on the composition. So if you have really high energy diets and that energy coming primarily from carbohydrates, that's going to result in a fattier carcass. Do people eat chicken or fish for fat? So is that desirable or undesirable? Undesirable. So you don't really want to have a super high energy diet. If you have higher crude protein, that's going to help cause it to be a leaner bird. So you can alter the fat composition by also affecting the dietary fat. So here, this is looking at moisture in the diet compared to, you have protein. So high protein, you end up getting, let's see. So if you have a higher body weight, you want a lower protein, or this is looking at the muscle tissue. So the heavier they get, the less moisture. With the body weight, the heavier they get, they have less protein, and they end up increasing the amount of fat within the carcass. finish this, and then I'll talk about the current metabolic problem that we have. We also have feather development. So our feather development, our feathers are composed of keratin, which is a protein. It's rich in cysteine. These are important to control body temperature. So if we don't have adequate feathering, we're going to need to provide them a diet with more energy. More critical with this if you're doing this in the winter. Skin, we want to reduce the amount of tears in the skin. So if you all have seen that chicken skin's really easy to tear, really easy to break. Different than pigs, humans, beef. So we want to make sure that we have good skin. When that skin tears, if it gets torn in the processing, the likelihood of you increasing the amount of salmonella has gone up, right? This used to be more of this was a bigger deal probably back in when people bought whole birds, but people don't really buy whole birds too much anymore. To where they would go and roast them at home or cut them up themselves. Now everybody buys it already cut up. So if you do get a tear, you can move it onto into the further cut up, but it all depends on what your initial plan was. Females are more susceptible to tears than the males. And a lot of that has to do with the collagen content. So collagen is the connective tissue that's holding together. Collagen and elastin, those are the proteins that are keeping everything, keeping you from looking old, right? So you want a decent amount of collagen and elastin within the skin. So you want to ensure that you have adequate zinc, copper, and vitamin C in the diet because that's going to help with the collagen synthesis. Current metabolic disorder that we are dealing with, which is what, today I had a great science day because I've been working a little bit on this project, but we have the woody breast. Have you guys heard of woody breast?
Mm-hmm.
So what's woody breast?
Remember the meat's real tough.
So you end up with the very tough, hard breast tissue. This typically is happening in your high yield, fast growing males. We don't know what causes it. We know if we reduce the energy and slow down their growth, we reduce the rate of woody breast. The other issue about woody breast is the USDA last July has now said that woody breast is an adulterant. Because if you have severe woody breast, that tissue is actually, if you look at it histologically, it's infiltrated with immune cells. So the USDA is saying this tissue has an infection. We don't know what the infection is. But if you have an infiltration of immune cells, that's indicative of some sort of infection, and you can't put diseased tissue into human food chain. So that's, since we're in a margins business, that's really hurting us, because before that, we used to take that and put it into chicken nuggets. Okay, if it's really severe, we put it in chicken nuggets. Well, now we can't do that. In addition, this tissue, if you look at it histologically, is all necrotic. Have you guys taken any meat processing classes, meat science classes?
I've gone to the processing plant.
But you haven't taken a
I haven't
meat class?
taken it.
So when you have necrotic tissue, so the thing that makes meat great and juicy and tastes good is its water holding capacity. Okay, so you want, that's part of the reason why you will marinate. You want the meat to pick up water, and then when you cook it, you want it, you don't want that to cook off. You want that protein to hold on to the water. So that's your showing your protein functionality. If your proteins are not, if they're denatured, if they're not working correctly, it's not going to be able to hold on to the water. So that's part of the reason why woody breast is called woody breast, because you don't have any, it doesn't hold on to any water, so it makes it very tough. And it feels like you're eating wood because it's so dry. So this is a major issue given the current climate that we're dealing with, and we don't know what causes this yet. So some have done some looking at breeding, some have looked at feeding. I look at physiology related to it, so trying to figure out what the cause is of this. So if we can figure out the cause, maybe some component is going to be dealing with nutrition, help reduce this rate of woody breast. Do you guys have any questions so far? We're done with broilers. I gotta talk to Mike. I don't know if he's gonna start next week on fish. If not, I'm gonna try and get through, do quick turkeys and layers. And then Friday, we're gonna have our feed ID quiz.
Sounds good.